All right, guys, today we're going over 4.4, which is proving triangles with SSS and SAS. So we're going to be able to use the SSS postulate to test for triangle congruency and use the SAS postulate to test for triangle congruency as well. So our first postulate is side, 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 which is SSS congruency. So if three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. So in this example, if side AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF, then triangle ABC is congruent to triangle DEF. Side angle side is the SAS congruency. So if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the angles or the triangles are congruent. So if side AB is congruent to DE, angle BE or B is congruent to E, and side BC is congruent to EF, then a triangle ABC would be congruent to DEF. And the key with these guys is making sure that the angle we find is in between the side and the other side, just like it says SAS, side SAS. All right, so determine which postulate can be used to prove that the triangles are congruent. If it is not possible to prove congruency, write not possible. So with this one right here, we have all the sides are marked congruent on both triangles. So since all the sides are congruent, we would use SSS. For number two, all we have are these two sides are marked, and we would also know that that middle one would be marked as congruent to each other because this line is gonna be the same distance for this one and this one. But other than that, we don't know anything else. So this is gonna be not possible. And then this guy right here, again, we have these two sides are marked and these two sides are marked. So we have two sides that are congruent, and then we have a random angle here. We can't just go ahead and assume that we cannot assume that these angles would be congruent or these angles would be congruent off that information. So therefore this one would be not possible as well. For 4A, identify the three-dimensional figure represented by the wet floor sign. So this is a wet floor sign. This is a triangular pyramid. And then if AB is congruent, or AB is congruent to AD and CB is congruent to DC, prove that ACB would be congruent to triangle ACD. So if this is B down here, by the way. So if this is B and they say AB and AD are congruent, and then CB and DC are congruent. So we're trying to prove that these two triangles are going to be congruent. So step one, we always write the given information. So it would be AB is congruent to AD and CB is congruent to DC, and that's given. So step two, we could then say that this line right here, this AC, will be congruent to AC, and we can say that because of the reflexive property. And since we've proven that we have side, side, side because we have all the sides taken care of. So triangle ACB will be congruent to triangle ACD by SSS. And then why do the triangles not look congruent in the diagram? So why do these not look the same? Because it's a three-dimensional object on a two-dimensional plane, because paper is two-dimensional. And this is a three-dimensional object. So 3D object on a 2D plane makes them look different. All right, so now we got some proofs here, more proofs. So we're going to write a two-column proof given that GH is congruent to KJ. So GH is congruent to KJ. And then HL is congruent to JL. So HL and JL. And L is the midpoint of GK. So L is the midpoint of this whole thing. So step one, let's write our given information like we always do. So GH is congruent to KJ. HL is congruent to JL, and L is the midpoint of GK, and that is given. So now number two, we have two sides, right? We have two pairs already, so that we can get this pair because of the L is the midpoint of GK. We know that if this is the midpoint of this whole thing, that these two sides would be the same. So we can go ahead and I'm gonna mark that on my picture. And that's gonna be my step two, that GL is congruent to LK. And that is the definition of a midpoint. And so we've got all three sides taken care of, three pairs. So we've got triangle GHL is congruent to triangle KJL, and that is by side, side, side. So now we're gonna go ahead and flip to the back where we've got all these fun proofs here. All right, so for the first one, the next one, we have triangle QRS is isosceles. QRS is this big triangle, and if we know it's isosceles, with QR is congruent to SR. QR is congruent to SR. And then RT bisects QS at point T. So if it's a bisector, that's basically works as a midpoint, so we can say that those two sides are congruent as well. So number one, rewrite our given information. Triangle QRS is isosceles, which I'm putting ISO. And that's with QR being congruent to SR, and RT bisects QS at point T. And that's given. So I can go ahead and say that I can do the QT is congruent to TS, or I can go ahead and do my RT is congruent to RT by my reflexive property. So I'll do that one first. RT is congruent to RT by the reflexive property. And then T is the midpoint of QS. That's the definition of a bisector, which is given to us right there. T is midpoint of QS. Definition of bisector. So therefore, we can now say QT is congruent to TS, which I already had marked. So QT is congruent to TS, and that's definition of midpoint, or the midpoint theorem, whichever one you want to put down. They're the same thing. So 5, again, we have all the sides now. So I can now say triangle QRT is congruent to triangle SRT by side, side, side. Number 7, are the two triangles congruent by side, side, side? Triangle ABC has vertices of A at 1, 1, B at 0, 3, and C at 2, 5. Triangle EFG has vertices at E at 1, negative 1, F at 2, negative 5, and G at 4, negative 4. So what we need to do here is we're going to have to do the distance formula for these triangles. We can graph them if we want to. We don't have to graph them because we're going to find the distance formula regardless. Okay, so I got to do the distance formula from AB. And if you don't remember the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared for our points. And so for this one, AB, I've got 0 minus 1 squared plus 3 minus 1 squared. So I got negative 1 squared, which is just 1. plus 2 squared, which is 4. So I have the square root of 5. And you usually leave them in square root form here. So now we got to do BC. So square root. I've got 2 minus 0 squared plus 5 minus 3 squared. So I got 2 squared, which is 4, plus 2 squared, which is also 4. So it's 8, the square root of 8. And then AC is the last one, so the square root. And we got 2 minus 1 squared plus 5 minus 1 squared. So we've got 1 squared, which is 1, and 4 squared, which is 16. So we got the square root of 17. So now I found the distance for the sides of the triangle ABC. Now I need to try to define the triangle. I need to find the distance of triangle each side of EFG, and they need to match up perfectly to this for them to be a side. If they don't, they're not. So I gotta do EF equals the square root. So F is 2 minus 1 squared plus -5 minus -1 squared. So I'll have 1 squared, which is 1, and then I got -5 minus a -1, so it'd be a plus 1, so it'd be 4 squared, so it'd be the square root of 17 total. So that matches up with our AC, so we're good still. Now let's do FG. So again, I'm doing the distance formula, so I've got 4 minus 2 squared plus -4 minus -5 squared. So I've got 2 squared, which is 4, and then I'm going to have -4 plus 5, which is 1 squared. So I got the square root of 5. So that matches up with AB, so we're still good to go. And then we got EG, and EG has to be the square root of 8, or they are not congruent by side. So EG, we've got 4 minus 1 squared plus -4 minus -1 squared. So I got 3 squared, which is 9. And then I got 4 plus 1, or 4 minus -1, but 4 plus 1, which is -3, so 9. So we have the square root of 18. So these two do not match up. So therefore, the ABC and EFG are not going to be congruent. So triangle ABC is not congruent, so it's a congruent sign with a cross through it. Triangle EFG. All right, so the wings of the hang glider shown below appear to be congruent triangles. If FG is congruent to GH and JG bisects angle FGH, prove the triangle FGJ is congruent to triangle GHGJ. So let's go ahead and mark our picture up. So FG is right here, GH is right here. So step 1, we always write our given information. So FG is congruent to GH. And JG bisects angle FGH. And that's JG, by the way. All right, so now number 2, it says that JG bisects angle FGH. So FGH is right here, and this is a bisector of it. So I can say that if this cuts this in half, that this side and this side will be congruent. So this angle and this angle will be congruent. So to write that, I'm going to put angle FGJ, which is this angle right here, is congruent to angle HGJ, which is this side. And 2, that's definition of an angle bisector. Step 3, because I've got a side and an angle, I need to use this side right here. And the great thing about this side, every single time we've got a side using one triangle and another and they're connected, we can use the reflexive property. So I've got GJ is congruent to GJ by the reflexive property. And now I've got a side, an angle, and a side. So step 4, triangle FGJ is congruent to triangle HGJ by side, angle, side. All right, last two. Given MN is perpendicular is congruent to PN and LM is congruent to LP, which is already marked there. So let's go ahead and write our given information. Okay. And we're trying to prove that angle LNM, so LNM, this angle right here, and angle LNP, this angle right here, will be congruent. So before I do that, if I look at this, I've got a pair, and I'm, again, just like over here and over here, I've got a line right here that shares both triangles. If LN is 5, it's 5 for this triangle and this triangle, so it's congruent to itself. So step 2, LN is congruent to LN, and again, that's the reflexive property. Okay, and now I've got these two triangles are congruent by side, side, side. So triangle LNM is congruent to triangle LNP by side, side, side. And when we do that, like in the last section, we can then say, because those are congruent and we know it, that means all the parts, including the angles, are congruent. So angle LNM will be congruent to angle LNP, again, because we proved that these triangles are congruent. And when we've already proven that these are congruent, and we need to find another angle, we always use the congruent parts of congruent triangles are congruent, which is Cpctc. All right, last one. BA is congruent to DC, and angle BAC is congruent to angle DCA. So let's write that down as our given information. Given. So step 2, just like we've been doing on all the other ones, AC is going to be congruent to AC for both triangles. So that's the reflexive property. And when I did that, I have a side, angle, side. So I can prove that these triangles are congruent. So triangle BCA is congruent to triangle DAC by side, angle, side. And we're trying to prove that these two sides are congruent, the BC and the DA. And when we do that, just like we did up here, we're going to use Cpctc. So for BC is congruent to DA by Cpctc. And that's all for section 4.